Today we'll be talking about scaling your startups application on AWS. So we'll be taking you through some best practices. We start talking about understanding scalability. We talk about benefit of scalability, core AWS scaling tools you can use. We talk about serverless architecture, microservices. Then we'll be moving on to some advanced topic. We're talking about infrastructure automation, how you can automate your infrastructure and your operation in the cloud. We talk about monitoring, cost management. So also we'll be talking about security-based practices. We talk about, then we have a recap about all the best practices we have been talking about. Then we also be talking about a case study, which is like a real-life scenario. What is scalability? So scalability basically is just you being able, your system or workload, being able to handle an increase in load or demand on your resources. So, and also scaling is more than just handling more user, like as they're taking in more user. So it's about how is your workload, your server, how is it performing, where there's an increase in traffic, and also are you being cost effective while at it. So that's just what scalability is. It's more than just handling more user and the likes. So and also, why do you need to scale in the cloud or scale generally? So now the startup needs flexibility to grow as demand increases. So increase in traffic will need to increase in the resources you need to handle those traffic. So that's just the simple reason why you need to scale. So now let's talk about the benefit of scaling. Yeah, so the first one is cost effectiveness. So while you are scaling, you'll be paying for only the resources you are using. So because you are scaling as the traffic increases, so they need to scale down also when the traffic reduces. So you won't be paying for any idle resources. So that means you are being cost effective when you are scaling. And also there will be an increase in performance. So even sometimes when you didn't predict the traffic increase in your workload, in your application, and there's like a performance issue, your user, your clients won't be happy with their experience. So they might not come back, which will not be beneficial to your business. So that's one of the main reasons why you need to consider scaling. Then also, it's when you scale, you will have put in place a mechanism to handle faults. Maybe there's a failure in one part, so you have to fail over to another, to a backup server. There's something like that. So that's one of the major benefits of scalability using AWS. Then let's talk about some of the challenges that startup faces when they are scaling in the cloud. So sometimes you might not be able to predict the traffic that we will be getting. So, but if you understand all the best practices that comes with scaling, that will be very easy for you to handle. Then cost management, mostly scaling also leads to increase in cost. But once you understand the best practices to follow, you will be able to handle cost management very well. Then also, lastly, I will just talk about performance under load. Once you don't handle scaling very well, there will be an issue with performance and latency, which will lead to an increase in the satisfaction of your client or user. So now, let's slide, please. Yeah, so here are the major scaling fundamental. So I will just be talking about this briefly. So we have elasticity and scalability. So elasticity, simply put, is the ability for your resources or your workload to quickly expand or decrease. So you are expanding or you are contrasting. So that's just elasticity. So why? Also, elasticity is more like a short-term goal. So maybe you have an immediate need that you need to meet. So that's where elasticity comes in. So you need to just quickly increase or decrease the capacity or the number of your server. So that's elasticity for you. While scalability is more like a long-term goal, a long-term strategy. You need to plan for very well. Maybe you are moving from monolithic application to microservices, or there's an increase in the demand of your services. So that means you are getting more traffic. So you need to consider scalability. You need to plan extensively for this, your scaling in the cloud. And also scaling majorly consider just adding more resources or going up in the size of your instances. It does not really cater for scaling down back when they are decrease in traffic. They're now talking about vertical scaling and horizontal scaling. So to put in simple terms, vertical scaling is about scaling up. So that means you are moving from a lower size of your server to a larger size. So for example, you are moving from T3 medium to T3 large instance. Why horizontal scaling is about scaling out. So you are adding more resources. That's just the major difference. And also, for vertical scaling, majorly it adds its own use case also, but you will get to a particular limit where you can't add more resources again. Like when you can't increase the power rather of your instances again. So we reach like a ceiling limit, right? So that's where horizontal scaling comes in. So you might want to consider horizontal scaling when you reach this particular limit. So let's move on to the next. So here are the major component of scaling you can use on AWS. On the compute layer, we have Amazon EC2 auto scaling. So EC2 auto scaling will help you to undo your scaling automatically. Maybe if there's an increase in traffic based on the policy you would have defined. Okay, maybe if there's your CPU utilization of your server, it has reached this particular threshold, let's say 85%. So I need to increase. So that's just target tracking. We have different type of scaling now. So we have target tracking. Target tracking will be monitoring your the metrics that you have defined for it to monitor. We have predictive scaling. Predictive scaling is about, okay, you already know, okay, at this particular point in time, you will be expecting an increase in traffic on your website. So we have predicted. So you have put in place this scaling policy and mechanism also. Why schedule scaling is, for example, most e-commerce websites, they will be running Black Friday this November, right? So automatically there will be an increase in demand on their workload on their website and application. So they will have scheduled this scaling. Okay, on this day, I need the number of servers to increase to this particular number. So that's just what that is about. Then on the container level, we have Amazon ECS, we have Amazon EKS, we have Amazon Fargate. So Fargate is a serverless container service, while EKS is Elastic Kubernetes service. It is a third-party open source container service, while ECS, Elastic Container Service, it is an AWS native container service. On the storage layer, we have Amazon S3. Amazon S3 is an object storage. So you can save your picture, mostly video, text. So mostly that's what you'll be using Amazon S3 for. You can also use it for your website static assets, to store your website assets. Then on the database, for the database option, we have Amazon RDS, we have Amazon DynamoDB. For the RDS is you have to provision the server yourself, while DynamoDB is fully managed, so it's serverless. AWS will handle the server for you, so we won't be managing any server or the likes. But RDS also is highly available. You can have replica across different regions to handle high availability. So for the network layer, we have load balancer, and we have different type of load balancer. We have application load balancer, network load balancer. So after auto scaling, I've already spin up your server. Maybe it has increased the number of your servers to, let's say, 5, based on what you define in the policy. So you need something to distribute the workload. So that's where the load balancer comes in. From the name, it balances the load. Okay, this server is not accepting much request. Let's send some traffic there. And also load balancer will do some health check for you. It will monitor the health of your server. Any server that is not healthy, it will remove it and replace it. And at that particular point in time, that server won't be accepting any request or traffic. It will be redirecting the request to other healthy server. So for the content delivery, we have CloudFront, global edge location. So CloudFront makes use of global edge location, and global edge location is simply just this data center that has been stationed all around the globe by AWS. So instead of, let's say you have a workload in US now, and you have customer or user in Europe, and they want to make use of your application. So instead of the the request will be going from Europe to US every time. So the first time the user make a request to your workload in US, if you have provision, if you have put in place CloudFront as a caching, as a content delivering system now, so it will store those particular contents in the data center in Europe. So instead of going to US every time, so this content will be stored in Europe. So that means there will be a reduce in latency. The performance of the experience and performance of your application will be improved as well. So on the automation and monitoring layer, we have CloudWatch. CloudWatch is used to collect metrics on your resources. We'll be talking extensively more about it later on. So I'm just doing like some brief introduction about all these services for now. Then for the infrastructure level, infrastructure as a code, IAC, we have AWS CloudFormation. So CloudFormation is the AWS native service for IAC, and also we have Terraform. Terraform is by HashiCorp, is the third service IAC provider. So next slide, please. So now we're talking about serverless. So serverless is one of the major best practices to employ when you want to scale in the cloud. So why will you make use of serverless? Because with serverless, you are not managing any server, and AWS is doing the managing for you. So that operational overhead has been removed from you, and you just focus on writing your code, your business logic, no managing of server. And also all the serverless services, they scale automatically. So, and we are talking about scaling, right? So that has been handled for you. There's no need for you to be worrying about defining the scaling policy and the like. If you are making use of a service like EC2, you have to handle the scaling yourself. You have to manage the server yourself. But with serverless, there's no need for that. AWS have taken care of all this for you. And also there are some case scenarios where you might want to consider making use of server and serverless architecture. For serverless architecture, you want to make use of it when your application won't be running every time. Maybe just when a user just wants to access it, that's when it should be running. So for you to save costs, so that's one of the benefits of using serverless. It will save you costs. You are only paying for what you use, because the server is not running every time. It's only when the request is being made. And also, okay, let me just mention, serverless mainly work based on events. An event now is maybe on your website, someone click a button, and that button has been integrated to one of the serverless computing services, which is Lambda now. So it will be triggered maybe when the button is clicked, when someone upload a picture, so it will be responding to those events. So that means it's only that time that the server will be spin up. So that means you are paying only for that particular period of time that server works, and it will be shut down that particular instance until there's another event again. So, and also it comes with automatic scaling, like I mentioned earlier, and there will be a reduce in operational value because you are not managing any server. So now we're talking about some of the key serverless service options you have on AWS. To start with, we have AWS Lambda. So I mentioned this earlier. So you only be running code in response to events. So I talk about what events are, right? So also it's scaled automatically from a few requests per day to 1,000 per second. Can you see that? That's quite a lot. So it's highly scalable. And for Amazon API Gateway will help you to build, manage, and deploy your APIs. So it also serves as an entry point for your API. It handles your HTTP requests and the like. So this is very useful for backend work. For you, you integrate it to your Lambda. Lambda will be integrated with API Gateway, and the request will be sent to from your front end. The request will be sent to the API Gateway, from the API Gateway to the Lambda. Then we have Amazon DynamoDB. So DynamoDB is a fully managed NoSQL database, and it's serverless as well, and it's scaled automatically. So like I said, all the serverless services, they scale automatically. Then for S3 is object storage that comes with high availability. So it has 99.999% availability. That's 9 11s. So to the next slide, please. So now we'll be talking about microservices. So after this, we'll be moving higher more. So why microservices? So mostly the traditional way of deploying application is making use of monolithic, right? Monolithic architecture. So that means all the different components of your workload, they are bundled into one package, into one place. But with microservices, everything will be broken down into smaller pieces. And those pieces, they will be independent on their own. So, and also, each of these smaller pieces, they will be able to handle a particular business function. So, for example, login, one part might be handling user management, one part might be handling payment processing, one part might be handling carts, maybe adding items to carts if you have an e-commerce website, right? So, an advantage of microservices includes independent scaling. So because we have broken down all these services into smaller parts, so if there's an increase in traffic in one part, so it can scale automatically on its own without affecting other parts. And it scaled down also. So scaling up and scaling down, it will be based on demand. Then it is easier to understand and maintain if you are making use of microservices. So as for the monolithics, so let's say, for example, the key people that work on your application, they are not around anymore, and you need someone to maintain the code base or to add new features. So that means they need to understand the code base and the whole workload first, right? So, but if it's bundled together, so it will be cumbersome for them to understand. But if it has been broken down into smaller pieces and they see how they all communicate with each other, so it will be quite easy to understand and maintain this way. And also there's an improving fault isolation because they have been separated. All these services, they are independent on their own. So if there's one breakdown on one part, it won't affect the other part. And also there will be a faster development cycle. We have like an increase in feature release. We'll be able to release features faster and faster. So next slide, please. Okay, so building scalable microservices on AWS. So firstly, we have ECS. So mostly all the container services, you can use them for deploying microservices in AWS. So ECS is container orchestration services. Kubernetes, you can use it to manage your Kubernetes services that are making use of Kubernetes. So we have Lambda also. Lambda is also ideal for microservices because it's event-driven, right? Then we have SQS, which is Amazon Simple Query Services. So SQS is used as a service to decouple your microservices. So because all your different components of your workload, they have been separated, right? So they still need to find a way to communicate with each other. So this is where SQS comes in. So SQS will be sending data or information from one service to another. Then we also have SNS. So SNS is a pub/sub service. So you subscribe to a particular topic, maybe an alarm or notification, and once there's an issue, you'll be notified, or a particular service will be notified as well. So move on to next slide, please. So now let's consider maybe you have an existing application that is not a microservice. Maybe it's a monolith, right? And you want to move it to microservice architecture. So these are major best practice to follow to refactor this application. So the first thing is for you to identify the core services on that workload. So the entire workload that you want to break down into smaller pieces, right? So you need to understand the core services. So for example, the login is a core service, right? Sign up is a core service, right? So you need to understand and identify them. Then you start with the non-critical components. So the one that if there's an issue, it won't affect your user or you as a business much. Then you migrate one service at a time. Then once you have done this, you validate and you optimize. Okay, you check, okay, this is working quite well. You check for anywhere where you can improve. That's where optimization comes in. Then you scale based on demand. So that's where the auto-scaling comes in. Next slide. Yeah, so now we are moving deeper now. We're talking about infrastructure automation. So majorly the automation comes in various ways. And but when people hear about automation, mostly they talk about CI/CD pipeline, IAC. So I'll be talking about IAC firstly. So IAC, as the name implies, infrastructure as code. You are deploying your infrastructure as a code. So you can make use of programming language. You can make use of IAC services like CloudFormation and Terraform that I defined earlier. And one of the major advantages of making use of this best practices, it will speed up your deployment and reduces human error. Okay, because normally if you want to provision a service on AWS, you can just go into the console. Let's say an EC2 instance, for example. Now you enter the console, you spin up the server, you do your configuration. That's just for one server, right? So now let's imagine that you want to do the same thing for 10 servers or 100 servers. Maybe your workload or your startup has grown a lot now, and you have multiple servers in the cloud. And even it's not even about just deploying. Maybe you want to maintain or you want to change some configuration. So doing this manually is prone to error because we are human, right? You might make some error in some configuration. So this is where IAC comes in. So because you are making use of you are making use of the same template, the error will be reduced. And also because you are making use of a template for all your configuration. So if there's an error, it will be flagged during the deployment, and it will speed up your deployment as well. And also it enables consistency across your environment, because normally at the best practices, you need to have different environment as well. That's another topic on its own. So you have development environment, you have test environments, then you have production environment. Sometimes some companies, they do have pre-prod also, that's pre-production environment. So once you are done with your dev environment, you move your workload. If it's working fine in your dev, you move it to test. So testing, you call your QA people to come and test the features, the new features or the changes or new updates you made to see if it meets the business requirements. Then also after that, you move to production. So if you are doing this manually, it's prone to error. Like anything can happen, right? But if you are using IAC, the same thing that's moving from dev is what is going to a test environment, is what is going to production environment. So this will help you to maintain consistency across your different environments. Then let's talk about the keys area where you might want to consider automation. Infrastructure deployment. This is what we have been talking about, right? Maybe you are doing resource provision, you want to spin up database, maybe you have the DynamoDB, your computing server now, EC2 instance, you want to spin it up. You can use any resources you want to spin up on AWS. You can use infrastructure. Also, maybe they change in configuration or you want to manage your configuration, you can use IAC for it as well. Then also for deployment pipeline. So this is talking about CI/CD. So some people do it manually. So best practice is for you to automate most of these things. Your testing, you automate it. Your deployment, your code building, you automate it. Also, your operational tasks, you might want to automate. This is not even might. It's also highly advisable to automate your operational tasks like backup management. So we would have scheduled maybe your backup. Maybe you are backing up the EBS volume or your EC2 instance. You are backing it up maybe at a particular point in time. We would have specified maybe every Friday back up all these snapshots. So there's no need to be doing all this manually. Scaling operation, you need to handle this manually also. You can do this using auto scaling. Security updates, you can make use of the AWS System Manager to patch maybe your OS or to get any security updates you want to get. Next slide. So we'll be talking about the key service you can use for automation on AWS. CloudFormation, I mentioned this earlier. So it's an IAC service to model and set up your resources automatically. Then we have code pipeline. So this is the AWS service to automate your CI/CD for code deployment. So under the code pipeline, we have code commits, which is the repo, where there are many services under code pipeline. We have code commit, we have code build, we have code pipeline itself that help you to manage your pipeline. So once you push to your code commit, which is your repo, your pipeline will be triggered. Okay, after you push, maybe you have some branches. You have your develop branch, other branches also. Maybe your different developer, they have their own branch also. So once they match to your main branch and the requests have been matched, the pipeline will be triggered and it will run some testing to check many things that they have put in place. So once everything is successful, your resources or whatever change that you make, it will be deployed. Then we have AWS CDK, which is cloud development kit. So this will help you to define your infrastructure in a familiar programming language. So for example, maybe you are skilled in programming language like Python or JavaScript. So instead of learning, you can decide to learn CloudFormation or Terraform as well from scratch. So, but you can also deploy your infrastructure using this programming language. So that's where AWS CDK comes in. Then we also have Terraform, like I mentioned earlier, you can use it across multiple cloud provider. Next slide, please. So now we're talking about monitoring for scalable application. So it is highly important for you to monitor your application workload in the cloud, because there are many times where you might want to make some improvements, but how do you want to improve what you can measure? So this is where monitoring comes in. So monitoring enables proactive scaling, cost management, and ensures high performance. So we will be talking more about monitoring under each services now. So Amazon CloudWatch, it helps you to collect and track metrics. So CloudWatch is a service that is highly integrated with most of these computing services like EC2 instance, AWS, the Lambda also. Maybe there's an issue, you can actually go and check the metrics and see what's going on. So you can use that to trace whatever is going on. So also, where you are there working with autoscaling, you have integrated it with CloudWatch to define the threshold, maybe your CPU utilization, your network utilization. Okay, once this CPU utilization, which is 85%, I want the autoscaling to be triggered and increase the number of instances from 1 to 3 to 5 based on your policy, right? Also, with CloudWatch, you can set alarms for autoscaling and reacting to changes, like I explained. And also, you can create visuals of your metrics with CloudWatch. So this will help you to understand your workload. You can visualize the metric to see, okay, this is what is going on with this particular server or set of server, right? So with this, you can make improvements or adjustments as demands arises. Also, there's also need to regularly review your metrics to fine-tune scaling policy. So you can make use of CloudWatch for this. Then also we have AWS X-Ray. So X-Ray is more like CloudWatch, but it adds different use case. So with CloudWatch, you can with X-Ray rather, you can use it for tracing and debugging in production majorly. So it will help you to be tracing every request coming into your workload, especially you can integrate it with Lambda. Every of your Lambda function, it will be monitoring the request. It will be showing you the performance of your Lambda function. It will help you to know where you can make improvements. If there's an issue with a particular request or Lambda function, it will help you to see where the problem is coming from, and you can trace it and to debug. So instead of going through from one part of your architecture to another to check where the problem is coming from to debug, X-Ray can help you to do this seamlessly. Then we have Trusted Advisor also. So Trusted Advisor will provide recommendation for you for cost optimization, performance, and security. So it will be monitoring your workload. That's Trusted Advisor, and to check for where you can make improvements, where you can save costs, where you can improve performance, or wherever there are security lapses, and how you can improve on this. Next slide, please. So now we're talking about cost management while scaling. So scaling often leads to increase in cost. So there's also need to optimize expenses when you scale. So for example, you have one EC2 instance before. So you have scaled to 10. So that means there's an increase in cost, right? But while there's an increase in cost, so there's also an increase in business value. if you look it from that perspective also. So, but there are some best practices you can follow to reduce your spending even when you scale, right? So the first one is considering the instances we want to use. So we have reserved instances, we have on-demand instances, we have sports instances. So for reserved instances, you might want to consider reserved instances where you have your workload that will be running for a long period of time. So for example, you have an application that will be running 24/7 and it will be running for like 1 year or so, not like for just a short period of time. So you might want to consider reserved instance. So with reserved instance, you'll be making like a 1 to 3 years commitment with AWS. So that means you'll be paying for that period of time. But it will save you a lot of money compared to on demand. It will save you like 75% compared to if you are going with on demand. So on demand is used for flexible workload. Maybe that workload is unpredictable. You don't know the request or the traffic you'll be getting. So that's where you make use of on demand. Or also maybe in your development environment or test environment, you are running some workload. You can make use of on demand in that scenario as well. Then for spot instances, so spot instances like you are borrowing a server from AWS themselves. Some of their internal server are borrowing it. But the downside for this is they can take it away anytime, and they will just give you like maybe some minutes notification. Oh, hello, we are taking down this server. Wrap up with whatever workload you are running on it, or provisioning it to another server. But so the case scenario why one might want to make use of spot instance is maybe you are running some batch jobs, or you have some non-critical workload, or you are doing some POC or testing, or maybe you are running some analytical jobs that are not critical, that can any workload that can be stopped at any time that won't affect your business process. You can make use of spot instance. And also it's 90% cheaper compared to on demand. So can you see the ways that you can save costs? If, for example, now if there's some people, you see some people, most of their workload, they make use of on demand, because as an organization, we do well architected reviews where we review your architecture, we tell you where to improve your costs, where to improve on security, performance, reliability, and the like, and cost as well. So mostly we see most of our clients, they make use of on demand for most of their workload. And normally all these server, they run throughout the year. So we always advise them to move from on demand to reserve, and they always see like a significant reduction in cost while at it. So the next one is automatic scaling versus schedule scaling. So like I mentioned earlier, we have different types of scaling. So based on your use case, you might want to consider, okay, schedule scaling. So I know I'm running a promo on my website. So that means there will be an increase in price, right? So that means I should schedule my scaling to that particular period of time. And once the traffic has reduced, I can scale down as well. Automatic scaling also, maybe that one you are tracking your metrics, the metrics of your server and the other resources that you are using. So that will be major criteria for you to scale. Then for right-siding instances, so sometimes you might have over-provisioned your server. For example, we are using the M family server type now. So that's for the machine learning instances now. Or maybe you are even using T3 large compared to using T3 medium. So once you have collected metrics over time, you would have noticed, okay, this server is not really doing much work. It's doing like the CPU utilization is like 20%. It's like 25%, like 40%. So that's one of the advantage of collecting metrics now again. So with that, you notice, okay, I've over-provisioned this server. And because you are over-provisioning it, that means you'll be paying more than expected. So with these metrics you have collected, you can scale down to a lower instance. So this will help you to reduce costs. Because you are making use of a lower instance, you won't be paying more as compared to when you are using a bigger instance. So the next one is making use of serverless where it is appropriate. So I've explained the case scenario where you might want to consider using serverless, right? So consider serverless or managed service mostly first. And if it won't work for your case scenario, then you can go for you managing your server. So next slide, please. So cost management while scaling. So we're talking about strategy more. So make use of serverless where appropriate. Make use of implement cost allocation rather to track spending. So this is where you are making use of cost tagging to track your spending in the cloud. Also optimize storage costs with Amazon S3 lifecycle policy. So S3 have different type of storage classes, right? We have standard, we have archive, we have infrequent access, we have infrequent access one zone. Standard is the most expensive. Archive is the least expensive. Standard is for storage or storage class or data that will be accessing frequently every time. Maybe you have some data stored that, okay, you need to access it maybe every week or every day. So that's where standard comes in. Archive is where it's used for backup mainly. Maybe you won't be accessing that data for maybe in the next 6 months. You just want to back up that particular server. So instead of making use of standard, because if you make use of standard for backup, you are spending more. You are not utilizing all these policy that AWS have put in place. Also, you can set up a lifecycle policy that can help you to automatically move your data from standard to infrequent access to archive now. So now can you see this is another form of automation. Then employ caching strategy where appropriate. So for case where there will be more read on your database, so you might want to consider making use of cache service. So we have a cache service called Elastic Cache on AWS. So AWS is built on Redis and Memcache. So those are the normal traditional caching service that we have. So caching will help you to, like I mentioned earlier, for CloudFront, the same thing applies there also. So for your database, instead of you going to your database every time to get a particular data, so that will increase the load on your database and the performance as well. So you can just cache those data like in that cache service, Elastic Cache. So that will serve like an intermediary between your database and your computing instance now. And then the last one here, we have visualize your spending and set budgets. So setting budgets will help you to know, okay, for this particular month, this is the budget this is your budget. Majorly, most organizations have the budget they want to spend on each workload, right? So there's a need for you to set budget as well. And while at that, you need to set alarm. So for example, if $1,000 is your budget, we will set alarm, okay, once you get to $500, let me know. Send me an email. Once you get to 800, send me. So for example, if 1,000 is for the total month, and by, let's say on the 16th of that month, you're already getting $700 or $800 bill. So you should have known something is wrong. So this will help you to track or trace if there's any anomaly in your environment, and it will help you to reduce any unexpected spending in the cloud. Also, the visualization part will help you to have an insight or a visual in your spending. Also, you can also use it for to communicate your spending to the top executive in the organization. Next slide, please. Okay, so now we'll be talking about security, because mostly security is about everything. Scaling increase complexity and also introduce more security vulnerability, because sometimes when your application gets popular more, so that means you open it to more attacks. Because if the application is not popular, the chance that it will be hacked is very low, right? But all these popular applications, they witness major attack a lot. But because they put in place security mechanisms, that's why we don't get to hear about them being hacked or breached. So some of the best practices for security while scaling in the cloud is implementing IAM policies to control access. So they need to control the access to your environment in AWS. So for example, you have people in the accounting, that want to monitor they want to monitor, have a visual on your spending, right? So they don't have any business with server or database. So you have to restrict their access. You won't give them the access to maybe to even read, to check the list of the server you have or whatever. You won't give them the access. You only give them the access to what they need. So that's what this is about. So what they need now is to check the cost, maybe Cost Explorer or AWS budget. That's the only service they have business with. Your junior engineer, mostly you won't want them to have access to your production environment. So you still the access to maybe development only. Then the next one is make use of AWS App and Shield for DDoS protection. So also this platform comes with AWS Shield like free at no extra charge. So that means you can make use of AWS Shield for your DDoS protection when you are making use of platform as well. So you are not paying extra for this. So this will help you to prevent any attack on your workload as well. Then regularly review your security inside. You can make use of AWS Security Hub. So this is a service that will collect all the security recommendation or insight across all the security service that they have, that you are making use of. So it will now be in a centralized place where you can now see all the security insight. Then the next one is making use of KMS to encrypt your data. Also SSL and TLS to encrypt your data. So with KMS, you can use it to encrypt your data address. SSL TLS is used to encrypt your data while in transit. Then also security group and network ACL. So these are like different level where you can protect your VPC, which is a virtual private cloud. So mostly you deploy your server inside the VPC. So you need to put all the security, you need to define your security groups, your network ACL. So basically security groups and network ACL, they are just firewalls that are protecting your environment. So next slide, please. So now let's do a recap on the best practices we have been talking about since. So first one here is start with scalable architecture. So if you are designing your workload from the start, maybe you don't have an existing workload, so have scaling in mind even from your design when you are designing your architecture. So start with scalable architecture. Also automate everything. Use IAC, CI/CD pipeline, backup management, like everything, your patch, security patching and the likes. Automate everything. Monitor and optimize continuously. Use CloudWatch, use X-Ray to monitor, to track your metrics, to alert, to AWS budgets and Cost Explorer for cost tracking and reviewing. And also they need to review your workload and architecture at large regularly. And best practice is for you to review it quarterly, and you review it for anywhere where there's a need for improving performance, then you make adjustment. Then also plan for failure. So AWS will always tell you this. Why they design all their infrastructure, their data center, the services, they've designed them to be robust. They will still tell you to plan for failure. Sometimes the particular region or availability zone might be down. So if you have planned for failure, your workload would have backup, maybe multi-AZ or multi-region. So if your particular zone is down, your workload can still be running in the other region or availability zone that you have indicated. Then also we have data management, have backup strategy, data lifecycle management. I mentioned about the S3 lifecycle policy earlier. So this falls under that. Then backup strategy. Sometimes when you hear people saying their server is down and you ask them where is your backup, maybe the data, the backup is still on the server that was down. So that's not a very good way to go about it. If you are backing up the data on your server, you should back it up in somewhere separate. Even if that particular server goes down, it won't affect that backup. Then security first. So you need to regularly audit access control. The people that have access control to your environment, you need to regularly audit it. Your encryption also is very important for you to encrypt your data. Even maybe, unfortunately, your environment got compromised. If you have encrypted all this, your data, maybe at rest or in transit, it will be very hard for you to expose your data, your client data to this hacker. So next slide, we'll be talking about a real life case scenario. So I believe we all know Airbnb. So they use AWS to scale. So we'll be just going through their journey from their early days to their advanced stage where they are now, their scaling journey on AWS. So they started with a monolithic application that was running on Ruby on Rails, and it was basically hosted on just one single EC2 instance. So after some times, they witnessed some increase in traffic. People are using their application more, they got popularized, so they moved to multi-instance architecture. So that means they are making use of auto-scaling to distribute their workload across regions now. And also, they are using load balancer to distribute all this traffic. Then also, they adopted Amazon RDS for database management. Next slide. Their next phase is rapid expansion. That's between 2014 to 2016. So that's when they migrated from the monolithic to a service-oriented architecture. That's from monolithic to microservice now. Implemented Elastic Cache for Redis to improve the performance on their database, which is RDS that we saw earlier, right? So they also utilize Amazon S3 for storing and serving their static content. And yeah, this is one of my favorite. They make use of CloudFront for their global content delivery. So because they have customer and clients across many regions across the globe, so they make use of CloudFront for people to have a good experience, better experience, because if they have their workload hosted mainly in, let's say, Europe or US only, so people in other part of the world, they'll be having performance issue when they're accessing the website. So they make use of CloudFront to reduce the latency. Then the advanced stage, that's 2017 to current stage. So they make use of AWS Lambda for specific microservices. Maybe some of their workload does not need to be running every time. So they make use of AWS Lambda for them. So that's the serverless compute that we mentioned earlier. They also make use of Amazon DynamoDB. DynamoDB is serverless and highly scalable for certain IVs, for low latency requirement and the likes. So I think that's that for the case study. And that is the end of my presentation. I will be taking questions now. Thank you very much for your time. If there's any question, I'll be taking.
Thank you very much, Bamishi, for that insightful presentation. So please, if you have any question, you can do it to put it on the Q&A comment section. So Bamishi, I have a question for you here. So how can startup ensure security while scaling their application on AWS?
All right, thank you for that. So for you to, I think I mentioned that briefly about security best practices, right? So you need to control the access to your environment. Who have access to what on your environment? So there's this best practices called least privilege. So we only give people the minimum access they need. It's not like you give them all the full access to the environment and later start reducing it. So for example, now if someone just wants to, maybe your developer, just give them only access to the services they need. And they don't need access to machine learning service, right? So sometimes you can just decide to work with it, which can increase your cost because all those machine learning services, they are quite expensive. So basically, you just restrict access to only what they need. And also encrypt all your data. Use KMS, you use TLS for data in transit. Then backup as well. Backup is also part of security. Maybe there's a security breach. If you don't have backup, there's nothing to fall back on rather. So there's a need to have a good backup strategy in place. So I hope I answered that.
Yes, thank you very much for that answer, Bamishi. And we have another question for you. Is what common security pitfalls should we avoid during the scaling process? Get my question, Bamishi.
Yes, I do. Thank you. Okay, so the security pitfall now is, I think, is related to the first question and answer. So you might want to avoid giving people like admin or everybody full admin access to your environment. Also, there's another thing. One of the best, one of the number one best practices that AWS recommend once you open an account on AWS, they will tell you to, once you sign up as a root user, they will tell you to create another admin account, even if you are the owner of the organization, you are the owner of the account. So they will advise you not to be using that root user for anything, because once someone gets access to that root account as a root user, maybe your credential got compromised and they can log into your account as a root user. Like it can be catastrophic. But if it's still like an admin, so the admin still have some restrictive access to what they can do. So that's just one of the major pitfalls that you need to avoid. Also, encrypt your data, because it won't be nice for you to explore. What's the English? What's the word now? For the hacker to have access to your data, to your customer data. So that's just the major security pitfall we need to avoid. I hope I answered that.
Yes. Thank you very much, Bamshi. Please do well to also put your questions here on the Q&A comment box. So Bamshi, there's another question for you here. So how often should we revisit our architecture to ensure it meets scaling needs?
Okay, so I will say quarterly. Yes, I get that. I will say quarterly, but it depends on your organization policy. Some organization might want to be reviewing it, maybe every month or every 2 months. But the best practice is for you to be reviewing your everything, your whole architecture, your metrics, everything. Review it quarterly to see where you can make improvement on. Maybe anywhere there's any security lapses, where you can make improvement. And sometimes also all these AWS service, the AWS is always improving on their services and releasing new configuration and the likes. So you need to be reviewing all these things to see, okay, this new service or new configuration, it's worked very well with my use case scenario. So, but if you are not reviewing all these things regularly, there's no way for you to know about them.
All right, thank you very much. Yes, thank you very much.
And also, at the final notes, so sometimes it might not be experienced to maybe manage your infrastructure yourself. So we have at Secure Intelligence, we have the capacity, we have the talent to help you manage maybe your infrastructure, provision your infrastructure, while you are focusing on your business logic, your code. So you can just bring that burden to us. Maybe you want to scale to maybe from 100 to 1 million users. We can help you to manage that instead of you worrying about that. Thank you.
Thank you for that, Bamshi. That was a good one. And also, before we wrap up, I want to share an exciting opportunity what we do at Secure Intelligence Limited. Also, so you can book a free one-on-one consultation with our cloud expert. So you can also get access to free AWS digital training exclusively for all attendees. So also you can also get started in our tech aspect. So we have Secure Intelligence. We also have CIL Academy. So in CIL Academy, what we do at CIL Academy, we have a 0 to 30 program where even if you have no idea of knowledge in tech, you can always transit from knowing nothing to becoming an expert in tech. And also, I hope you found today's webinar valuable, and also you'll be leaving with a practice tip that we can use also. And also, this session is recorded on our YouTube channel, so you can always go to our YouTube channel at www.youtube.com/secure_teams. I also have Instagram. You can go on our Instagram at @CIL_teams. Also on our LinkedIn, or you can always go on our LinkedIn profile on Secure Intelligence Limited, and also our Twitter at @CIL_teams. So thank you once again for joining us for today's webinar, and we look forward to seeing you in another webinar section. Have a wonderful day. My name is Olani Kawale.